Now in this lecture we find out the maximum area of a rectangle that is inside a triangle. In the drawing we have triangle ABC. Inside this triangle ABC we have this rectangle PQST, and our mission is to find out the maximum area of this rectangle PQST. In addition, we know that side AB of triangle ABC equals to 10 units in itself, side AC equals to 17 units in itself, and this is side BC of triangle ABC. This equals to 21 units in itself. Repeat again, our mission is to find out the maximum area of this rectangle PQST. So in the first step, we do a construction, that is to say from point A, we do perpendicular on PQ. Okay. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A in PQ, this point, as point M. In the next step, we'll extend the perpendicular AM by straight line until it touches side BC of this triangle ABC. And we will define the touching point of the extended perpendicular AM with this side BC of triangle ABC, this point, as N. By doing this construction, we can adhere those two angles. Those two angles, they are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. So those two angles are equal to each other. But this angle equals to 90 degrees according to our construction. Therefore, this angle must be also equal to 90 degrees in its size. Likewise, those two angles are also equal. Those two angles are defined also as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So those two angles are equal to each other according to the same rule. But this angle equals to 90 degrees according to our construction. Therefore, this angle must be also equal to 90 degrees. In the next step, we will define the length for this line segment BN as X. So what is the length of this line segment NC? From the drawing, it is very easy to see that NC in total equals to BC minus BN. Again, NC equals to BC minus BN. So I write it down. NC equals to BC minus BN. So NC equals to BC, BC is 21 according to what is given in the equation, minus BN. BN is X according to our definition. So in total, NC equals to 21 minus X. So I write it down. Yeah. This is line segment NC. That is equals to 21 minus X units in its length. In the next step, I'll copy this right triangle A and B in a new page, and we will implement the Pythagoras theorem in this right triangle A and B. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here by PT is the equation for Pythagoras theorem. Side BN of the right triangle NB equals to x according to our definition. The hypotenuse AB equals to 10 units according to what is given in the question. So actually, this is the right triangle NB that are coming from the original drawing. According to the Pythagoras theorem, in this right triangle A and B, the square of the hypotenuse is AB squared, and it must be equal to AN squared plus BN squared. Here we subtract Bn squared from this equation 1. And we get that according to this equation 1, An squared equals to AB squared minus Bn squared. An is the missing side, so we leave it as it is, so An squared equals to AB squared. AB is 10, therefore AB squared is 10 squared. It is 100. Minus Bn squared. Bn is x, therefore Bn squared is x squared. So conclusion we found out that according to equation 1, An squared equals to 100 minus x squared. In the next step, I'll copy this right triangle A and C in a new page, and we'll implement the Pythagoras theorem in this right triangle A and C. Here by PT is the version for Pythagoras theorem. The hypotenuse AC equals to 17 units in itself of the right triangle NC, and side NC equals to 21 minus x units in its length, according to what you have already found out. So actually, this is the right triangle A and C that the code from the original drawing. In this right triangle A and C, according to the Pythagoras theorem, AC squared equals to NC squared plus AN squared. Here we subtract NC squared from this equation, equation 2. And again, that according to equation 2, AN squared equals to AC squared minus NC squared. So AN squared equals to AC squared. AC is 17, therefore AC squared is 17 squared, that is 289. Minus NC squared. NC is 21 minus x, therefore NC squared is 21 minus x squared. So here, according to equation 2, we found out that AN squared equals to 289 minus 21 minus x squared. This is according to equation 2, while according to equation 1, we have already found out that AN squared equals to 100 minus x squared. So we have two different equations for the value of AN squared. Therefore, we create equation 3 that states that AN squared according to equation 1 must be equal to AN squared according to equation 2. AN squared according to equation 1 equals to 100 minus x squared, and it must be equal to AN squared according to equation 2. It must be equal to AN squared according to equation 2, and AN squared according to equation 2 equals to 289 minus 21 minus x squared. So actually we found out that according to equation 3, minus x squared equals to 289 minus 21 minus x squared. So here we open the brackets of this expression 21 minus x squared, and we get that according to equation 3, 100 minus x squared equals to 289 minus, and here we have 21 minus x squared. 21 minus x squared equals to 441 plus x squared minus 2 times 21 times x is minus 42x. So here we'll open the brackets of this expression. We get that according to equation 3, 100 minus x squared equals to 289, and we have minus before the brackets, so this expression after we open the brackets will be equal to minus 441 minus x squared, and here we have minus times minus is plus, so it is minus 42x equals to plus 42x. So according to equation 3, we actually found out that 100 minus x squared equals to 289 minus 441 minus x squared plus 42x. So here we have minus x squared on both sides of this equation, equation 3, so minus x squared will get cancelled. After cancelled minus x squared, In this side of equation 3 we left only with 100. In the other side of equation 3 we have 289 minus 441 plus 42x. So here we will add 441 to this equation 3. And we get that according to this equation 3, we have 441 plus 100 equals to 541, and it is equals to 289 plus 42x. So according to equation 3, we found out that 541 equals to 289 plus 42x. Here we subtract 289 from this equation 3. So you get that according to this equation 3, 541 plus 289 equals to 252. So 252 equals to 42x. Here we divide this equation 3 by 42. So you get that according to this equation 3, x equals to 252 over 42 equals to 6. Again, 252 over 42 equals to 6. So x equals to 6 units in its length. In the next step, we return to equation 1. According to equation 1, we found out that an squared equals to 100 minus x squared. But we just right now found out that x equals to 6. Therefore, we substitute x by minus x squared in this equation 1 by 6. And we get that an squared equals to 100. And here we have minus x squared. So x is 6, therefore minus x squared is 6 squared, that is minus 36. So in conclusion, I actually found out that according to equation 1, an squared equals to 100 minus 36 is 64. So an squared equals to 64. We take out all of this equation, and finally we get that an equals to the square root of 64, that is 8. So an equals to 8 units in its length. This is 9 segment AN. This equals to 10 units in its length. So I write it now. AN equals to 10 units in its length. AN equals to 8 units in its length. In the next step, we define the width of this rectangle PQST. The width QS is B. And we will also define the length of this rectangle PQST. It is actually PQSA. Repeat again. The length of this rectangle PQST equals to A, and the width equals to B according to our definition. We know that PQST is a rectangle, and all the angles inside the rectangle are right angles. Therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees, because those two angles are the two angles out of 4 angles of rectangle PQST. Therefore, each of them is equal to 90 degrees in its size. In the next step, we focus on this small quadrangle MQSN. Inside this small quadrangle MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside this small quadrangle MQSN, we have 4 right angles, and according to rule 6, any quadrangle that has 4 right angles must be this rectangle is not a square, so we relate to this small quadrangle MQSN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other, so a rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. What is the length for this line segment AM? And the length of line segment AM equals to AN minus MN. So write it down. AM equals to AN minus NM. So AM equals to AN, that is 8, minus NM, and M is just write down from that NM equals to B. So in total, MN equals to 8 minus B. AM equals to 8 minus B. Those two angles are defined as corresponding angles. I repeat again. Those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if you define this angle as alpha, then this angle must be also equal to alpha because those two angles are equal to each other. Likewise, those two angles, they both defined as corresponding angles, and therefore they are equal to each other according to the same rule that corresponding angles between parallel lines are equal to each other. Actually, those two angles are defined as corresponding angles, and they are located between the same two parallel lines PQ and BC, and therefore they are equal to each other according to the rule that I mentioned. The corresponding angles between parallel lines are equal to each other. So if this angle is beta, then this angle must be also equal to beta, according to the rule that I mentioned. Okay. In the next step, we prove that the big triangle ABC is similar to this small triangle APQ. So why the big triangle ABC is similar to this small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle that belongs to both triangles. So we can write down that angle A equals to itself as a common angle that belongs to both triangles. So actually found out that all the three angles of the big triangle ABC are correspondingly equal to all the three angles of this small triangle AQP, and therefore triangle ABC is similar to the small triangle APQ according to angle similarity rule. So I write it down. We actually found out that the big triangle ABC is similar. This is the sign of similar to the small triangle APQ. According to angle similarity rule. And we also know that in a similar triangles, the ratio between their heights must be equal to the ratio between their sides. Again, in similar triangle, the ratio between their corresponding heights must be equal to the ratio between their corresponding sides. So here it means that we know that the big triangle ABC is similar to the small triangle APQ. So here we get that the height AM in the small triangle APQ over the height AN in the big triangle ABC. So the ratio between the heights, that is AM over AN, must be equal to the ratio between the corresponding sides. This is to say it must be equal to PQ, that is the side of the small triangle APQ, over BC, that is the side of the big triangle ABC. It again, the ratio between the heights of the two similar triangles ABC and APQ is AM over AN, and it must be equal to the ratio between their sides, that is PQ over BC. AM equals to 8 minus B over AN equals to 8, and it must be equal to PQ is A, PQ equals to A, over BC equals to 21. So actually, according to equation 1, we found out that 8 minus B over 8 equals to A over 21. Here we first multiply this equation 1, and we get that according to this equation 1, 8 times A equals to 21 times 8 minus B. So here we divide this equation 1 by 8. Finally get that according to this equation 1, according to equation 1, A equals to 21 over 8 times 8 minus B. So here we open the brackets on this side of this equation 1, and we get that according to equation 1, A equals to 21 over 8 times 8 is 21, minus 21 over 8 times B, minus B equals to minus 21B over 8. So here we multiply this equation 1 by B, and finally we get that according to equation 1, AB was multiplied to both sides of this equation 1 by B, so it will be A times B equals to 21B, and here minus 21B over 8 times B is minus 21B squared over 8. So what is actually A times B? A is the length of this rectangle PQST, and B is the width. And the length times the width is the area of this rectangle PQST. So if we found out that the area of rectangle PQST is A times B equals to 21B minus 21B squared over 8. So equation 1 means that we have the area of rectangle PQST is function of B. Again, according to equation 1, we have here the area of rectangle PQST, that is A times B, is function of the independent variable B, the width B. Okay, B is the independent variable, and the area A times B is the dependent variable, because once we choose the value of B, the value of the area will be determined by the value of B. So A times B, that is the area of rectangle PQST, is the dependent variable, and B is the independent variable. Again, our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of this function area, A times B, because A times B is the area of rectangle PQST, or for which B is the width, for which B we will get maximum value of A times B, that is the area of rectangle PQST. So in order to find out what is the maximum value of A times B, we will differentiate this function area, and we will equate the derivative to 0. By doing this function, this operation, we will get the extreme points of this function area, and then in order to find out whether the extreme point that we found is maximum extreme point or minimum extreme point, we have to draw the graph of this function area, and from the graph itself we can easily find out whether if the extreme point B that we found, it is maximum extreme point or minimum extreme point. So we start with the first step. The first step, we will differentiate this function area and equate its differentiations, its derivative, to 0. This will be equation 2. Our mission is to find out the derivative of this function area. So D is the version for derivative, so we have to find out the derivative of this function area. That is actually 21b minus 21 over 8 times b squared. And we have to differentiate this function area according to the variable b. Okay? So this expression means that we will differentiate this function area according to the variable b. And then we have to equate this derivative to 0 in order to find out extreme points of this function area of rectangle PQST. Okay? So, what is the derivative of 21b? We know that the derivative of b is 1, and therefore in total the derivative of 21b is 21 times 1, that is 21. And what is the derivative of 21 over 8 times b squared? Actually, we know that the derivative of b squared is 2b, and therefore in total the derivative of this expression will be equal to minus 21 over 8 times 2b, and it is equal to 0. So actually found out that the derivative of this function area of rectangle PQST is equal to 21 minus 21 over 8 times 2b. So here we take 21 as a common factor out of those two expressions, and we get that So 21 is taken out as a common factor. So what is left from 21 after we took from it 21 as a common factor? What is left is actually 1. And what is left from this expression after we took from it 21 as a common factor? What is left is actually minus 2b over 8 and is equals to 0. So here we divide this equation 2 by 21. And you get that according to this equation 2, we have 21 over 21 is 1. So in this out of the equation we left only with 1 plus 2b over 8 equals to 0 over 21 is 0. So conclusion according to equation 1, we found out that 1 plus 2b over 8 equals to 0. So here we add 2b over 8 to this equation 2. And we get that according to this equation 2, 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression 2b over 2 by 2. And we get that according to equation 2, 1 equals to 2b over 2 is b, and 8 over 2 is 4. So in total, we actually found out that according to equation 2, 1 equals to b over 4. Here we multiply this equation 2 by 4. And finally we get that according to equation 2, b equals to 4 units in its length. So actually we found out that the extreme point of this function area of rectangle PQST is b equals to 4. So in the next step we will draw the function area of this function area of rectangle PQST. We create the graph of this function area in order to find out whether if the extreme point b equals to 4 is minimum extreme point or maximum extreme point. Actually, I already draw the function area of rectangle PQST. This is how it looks like. This is actually the area of rectangle PQST is function of b. In the y-axis we have the area, in the x-axis we have the width b. And from the drawing it is very easy to see that when b equals to 4, when b equals to 4 units, then the area of rectangle PQST is here. It is a little bit greater than 40 square units. So we have found out that the extreme point b equals to 4 is the maximum extreme point, because when b equals to 4, the area of rectangle PQST receives its maximum value. The area is here. So therefore b equals to 4. When b equals to 4, we get the maximum area of rectangle PQST. The only thing that is left to do is to put the value of b equals to 4 inside the function area of rectangle PQST. The function area of rectangle PQST is a times b, that is the area, is equal to 21 times b minus 21 over 8 times b squared. So we have to substitute b by 4 in this function area. In this way we get the maximum area of rectangle PQST, this rectangle, and that will be the answer to the question. So the area of rectangle PQST will be equals to 4. A times b is the area, of course. So the area of A times b equals to 21b. b is 4, so it is 21 times 4 minus 21 over 8 times b squared. b is 4, therefore b squared is 8 squared, it is 16. So the area of rectangle PQST equals to 21 times 4, that is 84, minus, in this expression we have 16 over 2 is 2, so in total the value of this expression will be equal to 2 minus 21, that is minus 42. So the maximum area of rectangle PQST equals to 84 minus 42, that is 42. So we shall find out that the maximum area of rectangle PQST is equal to 42 square units. And that is the answer to the question. Repeat again. The maximum area of this rectangle PQST equals to 42 square units. So we know that when the area of this rectangle PQST equals to 42 square units, then the width B is 4. So what is the length A of this rectangle PQST? What is the value of this length A of this rectangle PQST? According to equation 1, the length A is equal to 21 minus 21 over 8 times B. So the length A of rectangle PQST when the area is 42 square meters, it is the maximum area of rectangle PQST. The length A equals to 21 minus 21 over 8 times B. B is 4. So it is 21, and here we divide both the numerator and the denominator of this expression by 4. 4 over 4 is 1, so in the numerator we left only with minus 21, and here 8 over 2 is 4. So the length of rectangle PQST when B equals to 4 is 21, 8 over 4 is 2. So it is 21, and minus 21 over 2 is minus 10.5. So the length is 21 minus 10.5, that is 10.5. So we shall find out that when the area of rectangle PQST gets its maximum value, that is 42 square units, then the width B of rectangle PQST is equals to 4 units, and the length A equals to 10.5 units. A times B, it is the area of rectangle PQST, it is actually A is 10.5, B is 4, and 4 times 10.5 is 42 square units. Okay, so in the next step, we'll summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST that is located inside the big triangle ABC. In addition, we know that side AB of triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, and this is side BC that is equals to 21 units in its length. I repeat again that our mission is to find out the maximum area of this rectangle PQST. So in the first step we did a construction, that is to say from point A we do perpendicular on PQ. Again from point A we do perpendicular on PQ. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and PQ, this point SM. In the next step we extended the perpendicular AM by side line until it touches side BC of triangle ABC. And we define the touching point of the extended perpendicular AM with side BC, this point SM. By doing this construction, we created here 2 two angles. Those two angles are defined as corresponding angles, and they are located between the two parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are also located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. In the next step, we define the length of this line segment BN as x. So what is the length of line segment NC? The length of line segment NC equals to BC minus BN. That is to say, NC equals to BC, that is 21, minus BN, that is x. So in total, NC equals to 21 minus x. In the next step, I copied this right triangle A and B in a new page, and we provided the Pythagoras theorem of this right triangle A and B. This is the right triangle A and B, that occurs from the original domain. According to the Pythagoras theorem, in this right triangle A and B, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABN, it means that AB square equals to AN square plus BN square. Again, AB square equals to AN square plus BN square. Here we subtract BN square from this equation, equation 1, and finally found out that AN square equals to AB square plus BN minus BN square. So AN square equals to AB square. AB is 10, therefore AB square is 10 squared, that is 100, minus BN square. BN is x, therefore BN square is x square. So in conclusion, found out that according to equation 1, AN square equals to 100 minus x square. In the next step, I copied this right triangle ANC in the new page, and we implemented, this is right triangle ANC. So I copied this right triangle ANC in the new page, and we implemented the Pythagoras theorem in this right triangle ANC. This is the right triangle ANC that occurs from the original domain. The hypotenuse AC equals to 17 units in itself, according to what is given in the equation, and we have already found out that NC equals to 21 minus x units in itself. In this right triangle NC, according to the Pythagoras theorem, AC square equals to NC square plus AN square. Here we subtracted NC square from this equation 2, and finally found out that AN square equals to AC square minus NC square. So AN square equals to AC square. AC is 17, therefore AC square is 17 squared, that is 289. Minus NC square. NC is 21 minus x, therefore NC square is 21 minus x square. So according to equation 2, we found out that AN square equals to 289 minus 289 minus x square. This is according to equation 2, while according to equation 1, we have found out that AN square equals to 100 minus x square. So here we have two different equations for the value of AN square. Therefore, we get an equation 3 that states that AN square according to equation 1 because the equation 3 that states that AN square according to equation 1 must be equal to AN square according to equation 2. AN square according to equation 1 equals to 100 minus x squared, and it must be equal to AN square according to equation 2. AN square according to equation 2 equals to 289 minus 21 minus x squared. Here we open the brackets of this expression, 21 minus x squared, and found out that according to this equation 3, 100 minus x squared equals to 289 minus, and here we have 21 minus x squared equals to 21 squared, that is 441 plus x squared minus 2 times x minus 2 times 21 times x is minus 42x. So according to equation 3, we found out that 100 minus x squared equals to 289, and here we have minus before the brackets. We open the brackets. After we open the brackets, the value of this expression will be equal to minus 441 minus x squared, minus times minus is plus, so it is plus 42x. So So here we have minus x squared on both sides of the equation, so minus x squared will get cancelled, after we cancelled minus x squared, this side of the equation we left only with 100. On the other side of the equation 3 we have 289 minus 441 plus 42x. So according to equation 3, 100 equals to 289 minus 441 plus 42x. So here we added 441 to this equation 3, and find out that 100 plus 441 is 541, and this equals to 289 plus 42x. Here we subtract 289 from this equation 3, and found out that according to this equation 3, 541 plus 289 equals to 252, so actually according to equation 3, we actually found out that 252 equals to 42x. Here we divided this equation 3 by 42, and finally found out that x equals to 252 over 42 is 6. So x equals to 6 units instead. In the next step we return to equation 1. According to equation 1, an squared equals to 100 plus x squared. So an squared equals to what x is 6, therefore x squared is 6 squared, that is 36. So in total, a squared equals to 100 and x squared is 36. So it is 100 minus 36. 100 minus 36 is 64. So according to equation 1, we actually found out that a squared equals to 64. We took a root out of this equation and finally found out that a equals to the square root of 64, that is 8. So here, this is line segment AN. That equals to 10 units in its length. In the next step, we define the width of this rectangle PQST, the width is B, and the length SA. Okay, and then we know that, so PQST is rectangle, therefore those two angles must be equal to 90 degrees according to the rule that the sum of the angles in all the rectangles inside any rectangle are right angles. So those two angles must be right angles. And then we focused on this small quadrilateral MQSN. Inside this small quadrilateral MQSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral MQSN, we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we add to this quadrilateral MQSN is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle MQSN, side QS must be equal to the opposite side MN. But QS is B, therefore MN must be also equal to B. What is the length of AM? AM equals to AN minus AM equals to AN minus MN. I repeat again. AM equals to AN minus MN. So AM equals to AN, that is 8, minus MN, that is B. So in total, AM equals to 8 minus B. So we know that those two angles, they are defined as corresponding angles, and they are located between the two parallel lines PQ and BC, and therefore they are equal to each other. So if we define this angle as alpha, then this angle must be also equal to alpha because those two angles are equal to each other. Likewise, those two angles are also defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is beta, then this angle must be also equal to beta because those two angles are also equal to each other according to the rule that I mentioned. In the next step, we proved that the big triangle ABC is similar to this small right triangle. The big triangle ABC is similar to this small triangle APQ. So why the big triangle ABC is similar to this small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle that belongs to both angles, so I can write down that angle A equals to itself as a common angle that belongs to both triangles. So I actually proved that all the three angles in the big triangle ABC are correspondingly equal to all the three angles in this small triangle APQ, and therefore those two triangles are similar to each other according to angle similarity rule. I repeat again, the big triangle ABC is similar, this is the sign of similar to the small triangle APQ according to angle similarity rule. And whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides, or the ratio between their corresponding heights must be equal to the ratio between their corresponding sides. And therefore, here in our drawing, it means that the height AM in the small triangle over AN in the big triangle must be equal to side PQ in the small triangle over side BC in the big triangle. And again, according to the rule that I mentioned, if we implement the rule in these two similar triangles ABC and APQ, we get that AM over AN, that is the ratio between the corresponding heights, must be equal to PQ over BC, that is the ratio between the corresponding sides in the two similar triangles ABC and APQ. AM is 8 minus B over AN is 8, and it is equals to PQ, that is A according to our definition, over BC, that is 21. So according to equation 1, we found out that 8 minus B over 8 equals to A over 81. Here we cross multiply this equation and equation 1, and finally found out that 8 times A equals to 21 times 8 minus B. Here we divided this equation and equation 1 by 8, and finally found out that A equals to 21 over 8 times 8 minus B. Here we open the brackets on this side of this equation and equation 1, and finally found out that A equals to 21 over 8 times 8 is 21, and 21 over 8 times B times minus B equals to minus 21B over 8. Here we multiply this equation and equation 1 by B, and finally found out that 8 times B equals to 21B minus 21B squared over 8. What is A times B? A is the length of this rectangle PQST, and B is the width. And the length times the width is the area of this rectangle PQST. So according to this equation 1, the area of rectangle PQST that is A times B equals to 21B minus 21B squared over 8. So actually, in equation 1, we have the area of rectangle PQST that is A times B as function of B. B, the width B is the independent variable, and the area A times B of rectangle PQST is the dependent variable. Once you determine the value of B, the value of the dependent variable will be determined immediately. Okay? So our mission is to find out the maximum area of this rectangle PQST. Or in other words, our mission is to find out the maximum value of A times B, that is the area of rectangle PQST, or for which B, the value of A times B will get its maximum value. Okay, for which B, A times B will get its maximum value. In order to find out what is the maximum value of A times B, we have to differentiate this function area and equate its derivative to 0. By doing this operation, we will find out the extreme points of this function area, and then we have to draw the graph of this function area in order to find out whether if the extreme point that we found it is a minimum extreme point or a maximum extreme point. So in the first step, we differentiate this function area. That is to say, the differentiate D is the abbreviation for derivative of the function area, that is 21b minus 21 over 8 times b squared, and we differentiate it according to the variable b. So it is over the dv, it means that we did the derivative according to the variable b, that is the width, and then we equated this derivative to 0. So what is the derivative of 21b? We know that the derivative of b is 1, therefore in total the derivative of 21b is 21 times 1, that is 21. And what is the derivative of minus 21 over 8 times b squared? Actually we know that the derivative of b squared is 2b, and therefore in total the derivative of minus 21 over 8 b squared will be equal to minus 21 over 8 times 2b. Okay, so if I found out that the derivative of the function area is 21 minus 21 over 8 times 2b, and it is equal to 0. It is equal to 0 because on the mission we found out the extreme points of the function area. And when the slope of the derivative is 0, then you will get the extreme point. Repeat again. When the slope of the derivative is 0, then you will get the extreme points. And then we will draw the graph of the function area in order to find out whether if the extreme point that we found it is minimum extreme point or maximum extreme point. Here we took 21 as a common factor out of those two expressions, so 21 taken out as a common factor. What is left from 21 after for me 21 as a common factor? What is left is actually 1. And what is left from this expression after we took from it 21 as a common factor? What is left? It is actually minus 2b over 8. It is equals to 0. Here we divided this equation 2 by 21 and found out that here 21 over 1 is 1, so we left only with, in this side of the equation 2 with 1 minus 2b, and the other side of the equation 2 we have 0 over 21, that is 0. So according to equation 2 we found out that 1 minus 2b over 8 equals to 0. Here we added minus 2b over 8 to this equation 2, and finally found out that 1 equals to 2b over 8. Here we divided both the numerator and the denominator of this expression by 2. And finally found out that according to this equation 2, 1 equals to 2b over 2 is b, and 8 over 2 is 4. So in conclusion, according to equation 2, we actually found out that 1 equals to b over 4. We will multiply this equation 2 by 4, and finally found out that b equals to 4 units in its length. So the extreme point of this function area AB equals to 21b minus 21b squared over 8. It is actually the area of a rectangle PQST. The extreme point is b equals to 4. And then I draw the function area. I draw the graph of the function area to verify that the b equals to 4 is indeed maximum extreme point and not minimum extreme point. Actually, this is the graph of the function area of rectangle PQST. In the y-axis we have the area, the value of the area. In the x-axis we have the width b, or the value of the width b. It is very easy to see from the graph that when b equals to 4, then the area is in its maximum value. In this way, we verified that b equals to 4 is max extreme point, maximum extreme point, and not minimum extreme point. From the graph, it is very easy to see that when b equals to 4, the area AB is in its maximum value. Therefore, b equals to 4 is maximum extreme point of rectangle PQST of the function area. That is the area of rectangle PQST. Now, the only thing that is left to do is to put the value of b equals to 4 inside the function area in order to find out what is the maximum value of rectangle PQST. So, this is the function area. The function area of rectangle PQST, a times b, it is the area of rectangle PQST. It is equals to 21b minus 21 over 8 times b squared. So we have to substitute B, this function area, by 4 because B is the extreme point, the maximum extreme point. So we did it and found out that the maximum area of rectangle A times B, the maximum area of rectangle PQST is A times B. So A times B, the area of rectangle PQST, that is A times B equals to 21B. B is 4, so it is 21 times 4 minus 21 over 8 times B squared. B is 4, therefore B squared is 4 squared, that is 16. So the maximum area of rectangle PQST equals to 21 times 4, that is 84, and here in this expression we have 16 over 8 is 2, so in total the value of this expression equals to 2 minus 21, that is minus 42. So the maximum area of rectangle PQST is 84 minus 42, that is 42. In conclusion, found out that the maximum area of rectangle PQST is 42 square units. Okay, again, the maximum area of this rectangle PQST is 42 square units. That is the answer to the question. But here we actually found out that when the maximum area of rectangle PQST is equals to 42 square units, then the width B is 4. So what is the length A? We can find out what is the length A according to equation 1, that A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4. We did it, we found out that A equals to 21 minus 21 over 8 times B, and B is 4. So it is 21 minus 21 times 4 over 8. Here we divided both the numerator and the denominator of this expression by 4. 4 over 4 is 1, so in the numerator we left only minus 21, and 8 over 4 is 2. So in total the length A equals to 21 minus 21 over 2. Minus 21 over 2 is minus 10.5, so in total the length A equals to 21 minus 10.5, that is 10.5. So the length A of rectangle PQST is 10.5, the width B is 4, and there is the length times the height, that is 10.5 times 4, that is 42 square units. In conclusion, we found out that the maximum area of this rectangle PQST is equals to 42 square units. Okay, thank you very much.